This is part 2 of section 7.5. Johnny averages 30 miles per hour when he drives on the old highway to his favorite fishing hole, and he averages 50 miles per hour when most of the route is on the interstate. If both routes are the same length, and he saves 2 hours by traveling on the interstate, how far away is the fishing hole? Okay, I see rates, I see time, I'm talking about distance. I'm going to be using D equals RT. We're told that the routes are the same length, so that means our distances are going to be the same. And if we can find a way of talking about rate times time, we're going to get this. Okay, so what I'm going to do is I'm going to create a chart so I can get an idea of what's going on. We have 2 routes. We have the highway and we have the interstate. Okay, we know the rates for both. The rate for the highway is 30 miles per hour. The rate on the interstate is 50. Okay. Now we're given some information about the time. We're told that he saves 2 hours by traveling on the interstate. So however much time is spent on the highway, 2 hours less than that is spent on the interstate, so that would be T minus 2. I could have also made this T and then this T plus 2, and it still would have worked out. Okay, we are asked how far away is the fishing hole? Well, that would be our distance, which is rate times time. So our distance here would be 30T. And then the distance here would be 50 times T minus 2. Okay, now if our distances or if the routes are the same length, then we need to put an equal sign between these and solve. And it turns out that this isn't even a rational, we don't even need rational equations in this. It's just mixed in with the other types, so you should not panic if you end up setting up a problem where you don't need that. Okay, I'm going to distribute right here to get 30T is equal to 50T minus 100. Let's subtract 50T from both sides to get negative 20T is equal to negative 100. Divide both sides by negative 20. And you get T is equal to 5. So what have we found? We found time, and time is how long, the T is how long he drove on the highway. So this is, these are miles per hour, so 5 hours on highway. What are we asked to find? We're asked to find how far away is the fishing hole. We're not asked to find the amount of time on either of these. I need to take this 5 hours and I need to plug it into one of these two, and it really should not matter which one. I'm going to take this and plug it in here. The distance traveled is 30 times 5, which is 150. These are in miles per hour, so this is miles. And if I had done it the other way, I would have had 50 times 5 minus 2, which is 50 times 3, which is also 150. Okay, so those first few problems are types of word problems we've done before. There's slight differences, but the same basic type. Now we're going to talk about a new kind. I call them shared work problems. Okay, these kinds of problems involve 2 things either working together to complete a job or working against each other to complete a job. Okay, we need to use a type of thinking that we do very naturally. If you, for the sake of argument, we say that we know it takes 3 hours to drive to San Antonio from here. You're driving to San Antonio. If you've been driving 1 hour, how much of the job, which is driving to San Antonio, have you done? If it takes 3 hours and you've been driving an hour, you're 1/3 of the way there, right? Okay, so we're going to use this kind of thinking. If 2 things are working together, like if 2 people are working together to paint a room, we use this pattern. However much it takes the one person to do the job, plus the amount of time it takes the other person to do the job alone, we're going to add those together, and it's going to give us the amount of time it takes to work together. If 2 things are working against each other, and the classic type of this problem is that most bathtubs, for example, will fill up faster than they drain. So even if you don't plug the drain, you can, if you let it run long enough, you can fill up a bathtub. So it's draining out and it's filling up. It's going to take a lot longer to get the job done if the job is filling up the bathtub, but it can eventually get done. Okay, and in this case, the problem will tell us which of the two jobs wins out eventually, and we take the winner minus the loser, and that's going to equal them together. So let's look at an example problem. I'm going to work the one where they're working against each other because this is more complicated. If they're working together, it's a plus sign in the middle and the order doesn't matter. If they're working against each other, it's a subtraction and the order does matter. So let's look at a problem. Okay. A winery has a vat to hold Chardonnay. An inlet pipe can fill the vat in 9 hours, while an outlet pipe can empty it in 12 hours. So you can see that it's filling up faster than it would drain. How long will it take to fill the vat if both the outlet and inlet pipes are open? Okay, so the inlet pipe's job is to fill the vat, and it can do that whole job in 9 hours. The outlet pipe's job is to empty the vat, and it can do that whole job in 12 hours. Okay, which of these is going to win? How long will it take to fill the vat? So this one is going to be the winner, and this one is going to be the loser when I talk about setting up the problem. Okay, so let's talk about together. So if they're both open, it can do its job in X hours. That's the part we don't know, and that's what we're looking for. How long will it take to fill the vat if both are open? Okay. Now, what I said earlier is we have to use the type of thinking that we use when we go to San Antonio. If we know the whole job takes 9 hours, how much of the job can you get done in 1 hour? What we want to reduce this to is how much of the job can be done in 1 unit of time. Most of your problems is going to be in 1 hour. Sometimes it might be in 1 minute or 1 second or something like that, but we're always going down to 1 time unit. If the inlet pipe can do its entire job in 9 hours, then in 1 hour, it does 1/9 of the job. Okay. The outlet pipe can do its entire job in 12 hours. So in 1 hour, it does 1/12 of the job. Okay. And then together, it takes X hours. So that means I can do how much of the job in 1 hour? Well, look what I've done every time. I've done 1 over this, 1 over this. The pattern holds. I can do 1 over X of the job in 1 hour. Okay, so these are the values we're going to use. And since things are working against each other, we do the winner minus the loser equals them together. Okay, so the winner, which is 1/9, minus the loser, which is 1/12, is equal them together. Now, everything would be the same on the setup if things were working with each other, if they were working together. Everything here would be the same, except I would put a plus sign in the middle, and I would not have to worry about what order these were in. That's really the only difference. This really is the harder type of problem. Okay, now we cannot just cross multiply here because we have an addition or subtraction over here. We don't simply have one fraction equal to another. So I need to find the least common denominator. And our LCD here is going to be, well, I definitely need an X in it. With 9 and 12, 9 does not divide into 12. Double this, 9 does not go into 24. Multiply this by 3 and I get 36, and 9 does go into 36, so this is 36x. So I'm going to multiply everything here by 36x over 1. Okay, so if I multiply, just imagine distributing here. If I'm multiplying these two things together, the 9 is going to cancel with the 36, and I'm going to have a 4, because 4 times 9 is 36. 4x times 1 is 4x. Okay, now multiply here. This is going to be a minus sign. 12 goes into 36 3 times, so I'm going to have 3x times 1, which is just 3x, is equal to, here my x's are going to cancel out and I get 36. Now combine like terms right here and I get 1x is equal to 36. Okay, so what I've just found is that if both are open, I found x, and that's how long it's going to take. So it's going to take 36 hours to fill that vat if the outlet and inlet pipe are open. We would expect it to take a good amount of time longer to fill it up because it's draining out at the same time. So this is a reasonable answer. One other thing I want to point out is right here, if you had wanted to use your calculator and done 1/9 minus 1/12, you would see that it's 1/36. So over here, I would have had, if I could have gone right here, I could have had 1/36 is equal to 1/x. And then if you cross multiply, you get x equals 36. So if you aren't afraid of fractions, you can get your answer more quickly than finding the LCD and killing them. But this also definitely works. You'd get 36 hours no matter what.